And now for our third speaker for the Industrial 5G session, really happy to welcome Ethan Kuch. He's Principal Engineer at Advanced Manufacturing at ST Engineering, Advanced Networks and Sensors. Looking forward to an interesting presentation. You can see the title there, From Pilot to Scale, Journey in Deploying 5G for Manufacturing Use Cases. So Ethan, all yours. Thank you.
Sure. Good morning, ladies and gentlemen. So welcome to join me in my sharing from Journey in Deploying 5G. So my sharing today will be Pilot to Scale, Journey in Deploying 5G for Manufacturing Use Case. So just a brief overview of my company, ST Engineering Group. Thank you, Terence, and thank you, Fidaus, for mentioning some of the past collaboration that we have did with Singtel. And also stated in the earlier mention that of smart manufacturing use case in ST Engineering. So we are actually a global technology defense and engineering company headquartered here in Singapore, publicly listed on the Singapore Exchange. So our global operations spans from Asia, Europe, Middle East, and US. So you may hear some smart rail networks contract being won. So we have 5G installed in all these systems that we offer to our solution. We are engineering company, we are system integrator, we have our products in 5G, localized 5G in a box solutions. So our corporate purpose is actually to harness technology and innovation to enable a more secure and sustainable world. So as you can see in this slides, we have did a lot of things from smart ports, smart rails, but our advanced manufacturing products goes into these verticals, such as defense public security sector, where we collaborate with HTX and DSTA to come up with monitoring systems that leverages on 5G. So from tanks and manpacks comms in land system, civil to frigate electronics in defense for shipboard systems, radar and EW in defense aerospace, high-speed hardened communications and AI-powered digital systems, such as platform and command centers, to quantum encryptor in cyber security. Our advanced manufacturing actually supports them all. So just let me invite you into a vision of how we envision a smart factory enabled by 5G connectivity powers our manufacturing plant.
Smart manufacturing and the factories of tomorrow rely on both advancements in technology and in connectivity.
Here at ST Engineering, we are pursuing both. We believe that the 5G-enabled factories of the future will deploy autonomous robotics, video analytics, and intelligent sensors to optimize and orchestrate every activity on the manufacturing floor.
As we drive towards Industry 4.0, we are excited to deploy new 5G-enabled capabilities in our own manufacturing centers, so we can experience firsthand the challenges, value, and impact of 5G in the arena of manufacturing. By deploying a range of sensors, including video cameras, environmental sensors, and onboard tracking devices, we get a deeper understanding of what is happening across the board, tracking and predicting the health statuses of our equipment and environment. Implementing high-definition network cameras, allowing for faster and more precise AI-enabled inspections whilst reducing the margin of error. 5G also allows us to better leverage AR and VR tools, increasing productivity and changing the way we work. It enables remote support and even collaboration across factories and even countries. Beyond this, we have wider ambitions. A digital twin of our operations would allow us to plan for new scenarios, test new environments, and change operations on the fly, all without having to stop productions or make physical changes on the ground. It would strengthen productivity, support more agile process configuration, and change the way we anticipate and deal with issues and opportunities.
At ST Engineering, we are co-developing new capabilities with world-class technology partners and developing exciting new solutions that can readily be applied to the manufacturing sector and far beyond. We believe that 5G technology creates endless possibilities for industries, organizations, and our partners as we transform manufacturing environments and the way we build the world.
So that is the vision of what we have for our brownfield operations manufacturing plant in Singapore. So we believe that our vision is actually AI. How AI works in our smart factory is that it acts as a brain, interpreting fast streams of data from sensors, IT, OT machineries, and other systems. Our vision is that this AI combines all this data from video, vibration, temperature, RFID, to deliver a unified operation picture of the operational shop floor itself. So for AI to create this situation awareness, it is required for the AI to have context awareness of the plant. So what is happening on the factory shop floor is that it's not just automated, but adaptive, intelligent, and self-optimizing. So what we envision that it's being powered by augmented reality for hands-free operational support in our manufacturing by human operators, advanced data analytics for predictive insight and process optimization with all this data coming in from the IT and OT machines, full plant digitization where we drive data transparency and traceability across all our machines, uptime, collaborative robots, cobots in short, for flexible, human-centric production and safety. Then industrial IoT connectivity, linking all assets, system, and people in real time. So the value of this pursuit, we believe that it will drive faster decision, autonomous response, and agile workflow in real time. So one of the challenge, and a suitable connectivity that is enable all this revolutionary transformation, I4.0. So we are still at I4.0 and not at I5 yet. So 5G alongside I4.0 is not just complementary technology, we feel. It is interdependent. AI brings intelligence to the edge of operations in our manufacturing plant. It provides high-speed, low connectivity, as mentioned in the earlier speech by Terence and Firdaus. We believe that combining this technology in our plant is the key to unlock AI-driven automation for predictive maintenance, real-time situational awareness of the picture with scale, reliability, and security. So this is just what we have here in Singapore, our production plant. It consists of several brownfield manufacturing sites invested and built up over the years. So they still remain siloed. Until a few years ago, we decided we have a vision. We want to try out to link them up with 5G for a centralized command over this couple of sites, distributed sites. This creates situational awareness that allows for remote support and cross-site learning. So 5G, which is the backbone, forms a resilient operation for us, especially in distributed and global manufacturing setups for coordinated controls. So this is just a slide covering 5G on why it's useful for us. We believe that with low latency, it is enabling real-time robotics, autonomous response for transport, which is critical in motion-critical tasks. So unlike Wi-Fi or wired network, 5G is very deterministic, as shared earlier, because of its networks slicing, where we believe that we can prioritize critical operations over non-critical ones. But what we are looking for in ST Engineering as a defense company, we want to safeguard the data that we are working with. So this is why the private, secured, isolated environment offered by 5G is critical to us, as it offers an additional layer of security. So in our journey, we have tinkered with some use case that actually matches our needs. So it started off as autonomous AGV that handles intelligent material handling from point to point between stations. So AGV actually reduces manual intervention by human operators, which later I'll have a video showcasing the earlier days implementation of it. As well as AI-powered smart cameras, where we do AI-based quality inspection on printed circuit boards in our plants. As well as automation and cobots, where we use robots to do repetitive and high-frequency tasks by human operators, which is repetitive. And this actually unlocks value. And then we also have mixed reality communications devices that enables cross-site learning from our QA that is remotely hosted in our headquarters. So as you can see on the bottom, this is one of our early days proof of concept, where we have this board, PCB board, that actually runs through surface mount technology in our manufacturing plant. So once there is an AI-based comparison and visual inspection of this board, it will detect that any defects, it will automatically be rejected, which is handled by our next process. So as you can see, this is an early day where we are doing a camera that is scaffolded. Earlier, there is a slide that is actually mounted already in I think the Vietnam plant. But for early days, we have to do a proof of concept, proof of value, and then a pilot program. This shows an AGV mounted with a cobot arm, working hand in hand with scaffolded AI camera, performing which triggers a material transit if it detects there's a defect or anomaly. So usually it is waiting for transit by human operators. But with this end-to-end solution, this robot will actually automatically move it to a staging area, classifying it into defects or good PCB boards. So the earlier example actually showed the uncertainty of technical feasibility when implementing such projects. But the toughest of them all, to me, is actually about proving ROI to our bosses and managing their expectation. Because this, in a way, actually speaks to the business owner. What can we do? What can we do to provide the value from these projects itself? So without a clear, quantifiable story, even the most successful pilot, proof of concept, or proof of value is risk of being shelved. So our approach, we have proof of concept which answers the question, can it work? This is why we do small-scale initiative, usually in the range of weeks to maybe a couple of months, that allows us to test out new technology, identify early risks, and gather stakeholder feedbacks. Next, we have proof of value. This is usually the toughest. So business owner will usually ask, is it worth it? The ROI is hard to prove. It builds on the understanding from the POC demonstrating the quantifiable benefits of the solution. If the proof of value works, we move on to a pilot program. So in this case, as the example showed earlier, we move from scaffolded AI cameras to actually couple of smart cameras connected to MEC. Then after that, we roll out a pilot program that actually installed in a couple of production lines. So this is just a slide summarizing the challenges that we face. So one of it, we are not in a lucky position where we are doing a greenfield operations like Hyundai. But for ST Engineering, we have capabilities built up over the year. So we have the intrinsic problem of legacy infrastructure integration, where brownfield plants have entrenched systems that have OPLC systems, proprietary protocol. So it's usually a retrofitted solution that helps to augment the current technology and assets. So the hardest one is actually ROI uncertainty and justification. So the upfront investment cost for such technology is usually high. And in a high mix, low volume, as shown that we support different kind of functions and productions. So we are actually a high mix, low volume brownfield operation that makes it even tougher. Quantifying the efficiencies and projecting the payback are difficult, especially with no historical precedence on the value being provided. Next, we have to manage people, process and organization change. To drive something from the grounds up with existing assets is difficult. So we need to change processes. We need to convince people on what works and how integrating 5G impacts. It's not only just a technology that impacts, it enables. This is to ensure alignment across IT, OT, and other systems to make sure that they run smoothly and not affecting the business as usual. And the toughest, I think is covered in this morning's session, is the ecosystem fragmentation, where vendors have different kinds of standards, where we are using, and it's a high cost to be invested into one vendor, and the interoperability between vendors can vary, so does the support. So this is my ending slides. I would just like to summarize that from our approach from pilot to scale, we need to first identify high-value user case, set the objective, define the success metrics right, get early stakeholder engagement, find out what they want, what they do not want, and then this reduces the resistance down the line on the implementation roadmap. Next, you will have to find your best fit solution. Us being a brownfield manufacturing plant, we have legacy systems. We need to know what infrastructure that we are working with, deploy proof of concept and pilot to fail early, to fail early, to identify risks early, and identify creative ways to solve them with our vendors. So this is to make sure that this best fit solution ultimately serves the right people and not just doing the sake for innovation. We then evaluate and recalibrate. And try to iterate just from the early risk identified. And then we get scalable buy-in, so more proof of value to our business owner that this solution is actually working and deserve more funding to scale up. So with that, I will end my presentation slides. Thank you, Bob.
Okay, thank you, Ethan. Yeah, you know what I'm going to say now. Questions? Any questions for Ethan? About, so ST Engineering, if I understand you correctly, you supply 5G-enabled technology to your customers, but you use 5G in your own factories, is that correct?
Yes, that's right.
Right, okay. And these factories are in, where? In
so
Vietnam?
they are located in Singapore. We are also offering solutions to our overseas partner to have a 5G-enabled smart factory solutions. Right. So it's more of a containerized solution where we provide places with private 5G network and connectivity in their shop floor.
Right, okay. And you mentioned, sorry, we have, okay, please.
Okay, for the 5G applicability in the smart factory, right?
Yes.
Is it really you think is 5G is required in the factory for for inspection of this quality inspection of this product which you showed in this right, the surface defects or assembly or structural or label, whatever it is, right? Do you think the 5G is critical for this factory environment? My first question. And the second question is now, because on the edge you are able to accomplish all the competitions. You really don't need any on demand, right? So my question really is 5G. I don't see much scope in the factories so far, until unless you have informed decisions or more kind of diagnostic, go for the remote. Yeah.
Yes, correct. So the usual question is why 5G and not Wi-Fi 7, for example. So for this case, we are dealing with robots that is moving across the production plant, where we think that the handover of the AGV there is in motion critical tasks is important to us. And ultimately, we are buying into the vision that this ultimately will be a solution that we offer to other factory. So we want to a factory, and we want to be able to scale it and work with 5G from the onset.
About this, achieving the efficiency in the smart factory, right? That by leveraging all these technologies. Most of the manufacturing, like consumer electronics manufacturing and all, right? Now with the advent of AI and all, and many of us think that it's going to be replaced by all the on-ground resources. But now what we identified is it's about the accuracy and minimize the error and improve the productivity of the whatever the output, right? How 5G enable this, reducing the, let's say, for inspection of PCB or whatever it is, structural defects. Earlier, they used to take 30 to 40 minutes to do the one PCB or whatever it is. Because of this technology with the vision inspection systems, we bring out into function of 10x, right? Can you comment on this?
Okay. So for this, we are using AI-based vision technology for machine vision just to scan it. But of course, 5G is just the backbone of the operations that we can work with 3D automated inspection machine itself that comes with AI as well. So the compute may be on-prem or it may be on the cloud. But being on the cloud, which is on the multi-access edge compute, we are able to scale it to more factories. We are able to scale it to more factories itself. So there's a scalability buy-in over there.
All right, thank you for the question. With that, let's give our thanks to Ethan for that great presentation
Thank you,
about
Bob.
engineering. Thank you.